Welcome to the Calculus 2 class. This session, we're going to study alternating series test. So, first we're going to recognize alternating series and identify its alternating structure. So far, all the infinity series with finite sequence term. So from now on, our series is gonna be alternating the sign. That's what we call alternating series. If we identify alternating structure, we apply alternating series test to decide if it convergent or divergent. After that, we determine absolute or conditional convergence and explain their difference. First, let's talk about example of alternating series. Look at this series. Summation n equal 1 to infinity, negative 1.5, n minus 1. So I expanded this sigma, n equal 1, n equal 2, n equal 3. n equal 1 meaning is power gonna be 0, negative 1.5, 0 power. n equal 2 meaning is 2 minus 1, power gonna be 1, that's gonna be right here, negative 1.5, 1. n equals 3, you plug in the 3 there, that's gonna be 3 minus 1, power is 2, negative 1.5, so on. Now let's see this first term, that's gonna be 1. Second term is negative 1.5, 1, then negative 1.5. Third term is negative 1.5 square, meaning negative square gonna be positive 1 over 2 square. Fourth term is negative, fourth cube is negative 1, 2 cube. Can you see what kind of pattern here? 1, negative 1.5, positive 1, 2 square, negative 1, 2 cube plus. The sign is alternating. We call this alternating series. Another way you write this alternating series this way. AN equal, this part represent is sign. That part represents sign. Then BN gonna be positive sequence term. So this format, we have BN gonna be 1 over 2 n minus 1. We call this alternating series. Here is formal definition of alternating series. You see that this kind of form we call alternating series. Negative 1 n minus 1 gonna be represent sign, alternating sign. Alternating sign, Bn gonna be sequence, Bn always have to positive. So we're gonna say they are alternating series. Let's have first example, guys. Look at this one here. This one is form of alternating series. This one represents alternating sign. Let's expand this one, guys, right here. So n equal 1, negative 1, power is 0. So here is gonna be negative 1, power is 0, denominator 1. n equal 2, power is 1, negative 1, 1's power, denominator 2. n equal 3, power is 2, negative 1 to 2, denominator 3. So let's simplify this one, guys. First one is 1. Second is negative 1.5. Third term is 1/3. Fourth term is negative 1/4. They alternating sign. So when you see alternating series, you find the Bn. So An equal negative 1 n minus 1 Bn. Bn should be 1 over n. That's represent the sign, guys. Bn gonna be 1 over n. Let's have a first example of convergence of alternating series. We have alternating series. We will determine if this series convergent, divergent. How we gonna find out if this infinity series convergent, divergent? We have to find the partial sum, right? This series gonna be alternating series. So we wanna find S5, partial sum. S5 gonna be, we add from first term to the fifth term. That's gonna be 1 minus 1.5 plus 1 over 3 minus 1 over 4 plus 1 over 5. What is this sum? This sum gonna be S5. 5 term you add. That sum gonna be approximate 0.783. I sketch the bar. Now, second partial sum, I picked the S10. S10 meaning is I add sequence from first to the 10th term. That might be 1 minus 1.5 plus all the way there 1 over 9 minus 1 over 10. So I approximate this partial sum that's gonna be 0.645. So I sketch the bar. Next one is S50. Meaning is you add sequence from first to the fifth term. That's gonna be 1 minus 1.5 plus 1 over 3 minus 1 over 4 all the way 1 over 49 minus 1 over 50. So n is 50. Partial sum gonna be 0.683. Now next one is I find the partial sum is S100. The sum gonna be 0.688. Next one is I found and it's 1000. Partial sum gonna be 0.693. Can you see this limit of partial sum? That's getting close, 0.693, which meaning is this series gonna be converged. This alternating series converges based on the partial sum. So let's compare this alternating series to harmonic series we study. Let's compare two series we have here. Left series, this is gonna be alternating series. Right series is harmonic series. How related to series? Let's expand alternating series here. That's gonna be 1 minus 1.5 plus 1/3 minus 1/4. If you drop the order negative, so negative sequence make a positive, it's gonna be harmonic series. Here, 1 plus 1.5 plus 1/3 plus 1/4. You know the harmonic series is gonna be diverse. Previous slide we proved this alternating series converges. Why is different? Left series, they alternating sign. Right series, all the sequences are positive. Let's compare partial sum right here, guys. Here is a partial sum of alternating series. As we did, alternating series gonna be converged. When you find the partial sum of this series gonna be converged. On the other hand, this harmonic series partial sum is increased. So left side, partial sum is converged. Right side, partial sum of a harmonic series diverge. So alternating series here converge. harmonic series. If you drop all the negative, that's the diverse. Why? Because its negative sign here, 1 minus 1.5, that meaning is your sum is decreasing little by little. So this one is, the whole thing is A5, A10, A15, not keep increasing like right side, they increasing without bounded, but left side, they increasing with bound. That's why this is converse. Why this bounded? Because negative sign here. Now let's talk about what the alternating series test. First, this apply only alternating series, guys. First, you recognize if series alternating. Alternating meaning is right here, guys. Change the sign. That's the alternating series. If you know this is alternating series, you find the Bn. Bn is all the positive. Then B1, B2, B3 decreasing. Bn is decreasing. Limit of Bn is gonna be 0. You check two condition that alternating series satisfies this condition. You're gonna say this series converges. Do you understand that? Alternating series, Bn gonna be decreasing. Limit of Bn is 0. That series converges. Let's have first example. This is alternating series because this one is represent this series alternating. So what is Bn? Bn gonna be 1 over n. So let's check two conditions. Sequence Bn decreasing, limit of Bn going to 0. So B1 is 1, B2 gonna be 1.5. B1 is bigger. B3 gonna be 1 over 3. B2 is bigger. B4 gonna be 1 over 4. B3 gonna be bigger. Now Bn plus 1 equal 1 of n plus 1. Bn is 1 of n. N plus 1 is bigger than n. So this one is reciprocal. Bn is bigger. So that's the decreasing sequence. Now let's check limit. Limit Bn gonna be limited 1 over n. 1 over n and behavior 1 over n. Each term go to where? 1, 1 over 2, 1 over 3 going to 0. Now this infinity series satisfy two conditions. By alternating series test, we're gonna say this alternating series converges. Let's check the graph of series and sequence, guys. First one is this represents sequence. Sequence is alternating, but they keep going to 0. Infinity series, partial sum of this series gonna be first one is here, second term here, up and down because the negative sign, but they convert some values right there. So that's we're gonna use alternating series test. For the alternating series, you have to check two things. Sequence decreasing, limit of sequence going to 0. Let's have another example. This one also alternating series because this term, this one. Okay, guys, this one. Now you find the Bn. What is Bn is n over 2n. First one is you have check sequences decreasing. B1 is 1.5. B2 gonna be 2 over 2 scale 1.5. They are same. It's okay, guys. B3 gonna be 3 over 2 cube. 3 over 8. That's definitely 1 over 2 is bigger because 1 over 2 gonna be 4 over 8. Now B4 gonna be 4 over 2 fourth power, 4 over 16, that's 1 over 4. Of course, 3 over 8 is bigger 2 over 8. So B3 is bigger. Now you know that this is decreasing sequence. One more thing you have to check, limit of Bn. Limit of Bn is n over 2n as n approaches to infinity. Top is going to infinity, bottom also increasing. You can use L'Hopital rule. If you don't remember derivative 2 to the n, it's fine. Derivative 2 to the n is 2 to the n times ln 2. So we're gonna differentiate, numerator, denominate. Derivative n is 1. Derivative 2 to the n is 2 to the n times ln 2. So you have 1 over 2 to the n times ln 2. N is increasing, 2 to the n also increasing, which meaning is 1 over 2 to the n going to 0. We prove two conditions, decreasing and limit of Bn going to 0. We're gonna say this series, alternating series, converges because of alternating series test. Let's have another example for alternating series test. Can you see that this one right here, guys? This one is represent. This is gonna be alternating sign. So this is alternating series. You're gonna find the Bn. Bn gonna be n plus 1 over n. But before you try the alternating series test, you have to do divergence test. Limit of Bn, find the limit of Bn, that's gonna be limit n plus 1 over n. You're gonna apply L'Hopital rule, derivative of n plus 1 is 1, derivative n is 1, the limit is 1. This one is not 0, so we're gonna say by the divergence test, the alternating series is gonna be diverse. Alternating convergence divergence test say limit of Bn is not gonna be 0. Then that series is gonna be diverse. Even though this is alternating series, we don't have to apply alternating series test. If this general term not going to 0, then that series is gonna be divergent. Let's talk about different convergence, okay? You see that alternating series right there. This is alternating series, right? This one is represent alternating series. So this is alternating series. When you expand it, guys, expand it 1 minus 1 over 2 square plus 1 minus 3 square minus 1 over 4 square plus keep going. So I'm gonna drop the negative sign here, which meaning is we're gonna make this alternating series of to the series with all the positive term. Then you're gonna see 1 plus 1 over 2 square plus 1 over 3 square plus 1 over 4 square. So this one looks familiar. That's the P series. P value is 2. So this series converges. Why? Because P value is 2. So 2 is greater than 1. This series converges. So compare two series. This one. Which is series? Sum of which series is bigger? This is negative. This is all the positive. Definitely P series is bigger. We know this P series converges. It can be diverse. Okay, this one. So we know that this one is converges. Or we're gonna say converges by alternating series test. What do you tell us about this one? This one is alternating series right here. You make all the sequence in the series. That's the P series. This series converges. Original series converges. We're gonna say this alternating series gonna be absolutely converge. So you have two series right here. Original series is alternating series. You make all the sequence in the series positive. Then you have P series right here that also converge. We will say this alternating series absolutely converge. Very powerful convergence, guys. Let's have a different example. We're gonna say conditional convergence this time. Look at this alternating series. Then now I have alternating series, expand the sigma. That's gonna be 1 minus 1.5 plus 1/3 minus 1/4 plus. Now you drop the order sign, make these sequences positive. You have 1 plus 1.5 plus 1/3 plus 1/4. Looks like what? Harmonic series. So here, harmonic series, p-value is 1. That's gonna be diverse. But left side, alternating series, we prove this one is converge because alternating series test. Then what are you gonna say here? Here is two different things. You drop the order negative, make all sequence positive, that's diverse. But alternating series is converge. Then original series gonna be, we say, conditionally converge, which meaning is the alternating series, when you make a sequence positive, then that infinity series gonna be diverse. But original series, alternating series converge, then this alternating series conditionally converge. Let's have formal definition of absolute convergence, conditional convergence, which meaning is series gonna be, guys, here is a series, that's the original series, converge absolutely meaning is you take absolute value. The other way is that you drop all the negative sign, make a sequence in the series positive, then this series is gonna be converged, that we say absolutely converged. But original series gonna be converged by absolute value of the series. You drop the negative there, then make all the sequence positive, that the diverse, then we're gonna say original series converge conditionally. If your series gonna be absolutely converged, that's very powerful convergence. So make sure understand difference between absolutely converge, conditional converge. Let's have first example. Let's decide if this series converges diverse. When you see this series gonna be, first you notice sign n is oscillating, keep changing. So we wanna find this series converge diverse. First, we're gonna take absolute value, guys, okay? Absolute value is sin n over n squared. So sin value doesn't have negative sign. Also, sin n is, absolute value sin is always less than 1. So absolute value sin n over n squared is always less than 1 over n squared. You know the infinity series 1 over n squared, that's the p series, always converge because p value is 2, that's greater than 1, that's converge. Now, what are you gonna say? Summation, absolute value, inside always positive, that's gonna be less than summation 1 over n squared. But you already know this series, P series converge. This is converge, left series less or equal to right series, which is converge. We're gonna say left series also converge. Direct convergence test. Direct comparison test, right, guys? Now, you're gonna take absolute value inside. sequence in the series is always positive, then we're gonna say this series gonna be absolutely converse, which meaning is all the series with absolute value converse and original series also converse. So we're gonna say this is absolutely converse. Another example, let's decide if this alternating series converge diverse. So when you see this series, let's check it out here, guys. Let's check it out. Take absolute value of each sequence inside, right? That's absolute value gonna be signage drop, -1 and n-1. Negative, absolute value -1 is always 1 over square root to n. Let's check it out, this series. This is a P series. P value is 1.5, less than 1, greater than 0. That's the diverse, okay? That's gonna be diverse. Now, what are you gonna say? When you take absolute value, which meaning is each term is positive, that's gonna be diverse. Now, we have checked original series. So how about this series? That's the alternating series. Bn gonna be n over square root to n. You can check it out. Bn is decreasing. Limit of Bn is going to 0. So alternating series test confirmed this alternating series gonna be converged. So now, what do you know? When you take absolute value of sequence and find the sum of series, that's gonna be diverse. But original series is converse. We're gonna say this original series conditionally converse. This is another example, guys. So we wanna decide if this series is going to be converged diverse or absolutely convergent, conditionally convergent. When you see alternating series, we say Bn gonna be 0 or not. So this time, don't jump into alternating series test. Just look at the Bn. Bn gonna be n over 2n plus 1. Find the limit of this sequence. That's gonna be n over 2n plus 1 as n approaches infinity. You can use L'Hopital rule. Derivative of n 1, derivative 2n plus 1 is 2, 1 over 2. That's not 0. Divergent test to say this one gonna be divergent. Okay, guys, you don't jump into alternating series tests all the time. First, check the general term that's not going to 0. Then by the divergent test, that's diverse. What do you learn in this session? First, we recognize alternating series. Alternating series change the sign term by term. So they have -1n, but you have find -1n's term. Sometimes they doesn't show it. Then in that case, you expand the sigma, check it out. Then when you recognize series gonna be alternating series, you're gonna use alternating series test. Bn is not gonna be 0. You're gonna say divergent. But Bn is, limit of Bn is gonna be 0. Then decreasing. Then you're gonna say converge. Then another thing we learned this session is absolutely convergent, conditionally convergent. Absolutely convergent meaning is when you have alternating series, you make negative term into the positive term. So infinite alternating series gonna be all the sum of positive sequence. Then that's gonna be converse. original series gonna be absolutely converge. Otherwise, we gonna say alternating series gonna be conditionally converge.